Well, bolts of uniform strength. So you know what is meant by the word strength. So it is the ability to prevent failure. So what do you mean by bolts of uniform strength? So it means, see, every bolt will have certain length. So for example, if you take this bolt, it has certain length. If this bolt has uniform strength throughout its length, then this bolt is safe. Otherwise, for example, let me take an example. So let us take a bar of this kind. Now this is subjected to a tensile load of P. Now what happens if it is stretched? Where will the failure occur? Can you tell me? What is the possible place of failure? Here, here, or here? So it will fail at the area where the cross-sectional area is minimum. Is it right or not? So it will fail definitely at the place where the cross-sectional area is minimum. So here it will fail. Why? What is the reason? Because at minimum cross-sectional area, the stresses developed are more. So here also the stresses are developed. So for example, sigma 1, sigma 2, and here for example sigma 3. At each and every cross section, the stresses are developed. But the stresses developed at the lowest cross section are more than that of the highest cross section, the larger cross section. So that's why the failure occurs at larger stressed area, highly stressed area, that is at the area of minimum cross section. So here we cannot say that this rod is of uniform strength, because here the stress is one value, here the stress is having one value, here the stress is having another value. This bar, here this bar is also subjected to a tensile load. Now the stresses developed in this bar, if you observe, the stresses developed at this section, at this section, at this section, at this section. So throughout the section, the stress developed is having a single value. Okay, so that's why this is called as a bar of uniform strength. This is the bar of uniform strength. But here in this case, since the cross-sectional area varies from place to place, the stresses developed are also varied. So that's why this is a bar of non-uniform strength. So here the failure occurs at the minimum cross-sectional area. Definite, no doubt in that. Okay. Now, which is preferable? Bar of uniform strength is preferable or non-uniform strength? Bar of uniform strength is always preferable, because it can resist more value, more loads. It can resist higher loads than that of non-uniform strength. The same is applied to our bolts also. If you observe from the side view, for example, I am here drawing, okay. So this is the major diameter, that means this is the major diameter, and here these are the root portions. Am I right or not? So at root portions, it is having one more diameter, small diameter, that means smaller area. So it is having larger area at the crest portions, and it is having smaller area at root portions. Now can you say that this is of uniform strength? No, because it has variable cross sections throughout its length, threaded portions. So that's why if this is subjected to load, what is the possible place of failure? It may fail at any place where the cross section area is minimum, especially at the root sections. It will fail. So that's why in order to make this bolt of uniform strength, or if you want the bolt to be uniformly stressed throughout its length, we have two options. See, this option and this option. First of all, this option. Now tell me, what is the difference between this one and this one? What is the difference between this one and this one? So here, the diameter of the shank, and observe, and the diameter of the portion at the roots. So here the root diameter is less than the diameter of the shank. So here, this is the diameter. The diameter of the shank is equal to the major diameter, and root diameter is lesser than that one. But here, if you observe, the root diameter is equal to the shank diameter. The diameter of the shank is equal to the root diameter, and the major diameter is greater than the shank diameter. Is it clear? So, by using this type of cross section, the stresses developed can be made uniform to some extent. See here, whatever be the stress developed here, the same stress is developed here also, because the area is same. Of course, here you may experience lesser stresses, but it is not subjected to failure easily. So here also you cannot say that this is a bolt of uniform strength completely, because at this point, at crest, you are having lesser stresses, and at the shank portion and at the root portion you are having lesser stresses, same stresses. So this is one option to prevent the failure, and the best option is this one. So what is this? This bolt is just similar to this bolt. That means the shank area is equal to the area at the crests. చూసారా, ఇక్కడ ఏరియా, ఇక్కడ డయామీటర్, ఇక్కడ డయామీటర్స్ ఉంటుంది, ఒకటి ఉందా లేదా? జస్ట్ లైక్ దిస్ వన్. ఎక్కడైతే ఈ రూట్ డయామీటర్ ఇది ఒకటి ఉంది, బట్ ఇక్కడ షాంక్ డయామీటర్ ఇది ఒకటి ఉంది. బట్ అలా ఉంటే షాంక్స్ దగ్గర మనకి రూట్స్ దగ్గర ఎక్కువ స్ట్రెస్ డెవలప్ అవుతుందని చెప్పుకున్నాం. సో దాన్ని మనం ప్రివెంట్ చేయడానికి ఏం చేస్తున్నామంటే, ఇందులోంచి వీఆర్ మేకింగ్ ఎ హోల్ త్రూ అవుట్ ద షాంక్ పోర్షన్. యు ఆర్ మేకింగ్ ఏ hole of DH, diameter DH. So what is happening by making a hole? The cross-sectional area of the shank portion is also reduced. The cross-sectional area of the shank portion is also reduced. Okay, so here now the cross-sectional area at the shank portion is equal to the cross-sectional area at the root portion. Is it right or not? So we will make a hole in such a way that the cross-sectional area at shank is equal to cross-sectional area at root. Now obviously the stresses developed are same at this point and at this point. Is it right or not? So now we can say that this bolt is of uniform strength. So in the first case, the stresses developed are different. At shank portion one stress is there, and at root portion one stress is there. So that's why it may fail at root portion. But here in this case, the same stress is developed at root portion, and at the shank portion the area is same. Here we have reduced some area by making a hole. Since the area is same, the stresses developed is also same. So then we can say this is a bolt of uniform strength. So that's why this bolt can withstand higher load than that of this bolt, because the stresses developed are minimum here and it is of uniform strength. Now here our task is, so in order to make it uniform, you have to make a hole. So how much diameter hole has to be drilled in order to make this cross-sectional area is equal to the cross-sectional area at the root? So here we are removing certain area. Is it right or not? Here removing certain cross-sectional area. So that must be equal to, so that area is 5/4 DH square. This must be equal to the difference at this area. So the difference at this area is 5/4. Here this area is D square. Am I right or not? That area is D square. In that we have to remove this area. So this is the root area, 5/4 DC square. Now if you equate dh square is equal to d square minus dc square. So dh is equal to root over d square minus dc square, where dh is the diameter of the hole, d is the major diameter or normal diameter, and dc is the root diameter. So here, this is the difference in area. Is it right or not? This is the difference in area, that means this area. So here also you are making hole. So this is equal to the difference in area at this portion. So making a hole of this much diameter, you can make this bolt of uniform strength so that it can withstand higher loads than that of our usual bolt. Right? Thank you.